Hello, everyone. In this video, we will look at handling collisions using separate chaining. In the preceding video, we look at handling collisions using open addressing. Now, let's look at separate chaining. Separate chaining here, we're going to have this hash table, but we're not going to put the elements directly into the table cell. Instead, and each table cell is a reference to a list. So the list is a bucket. So the bucket is going to hold and all these elements mapped to this location. So for example, here is 4, it's right here. And 26 is mapped to this location 4. You're going to put it into this list right here. So let's look at some examples here. I'm going to have this, this is one here. Let's have, this is 23. So 23 is going to be right here, mapped to this location 1. And you're going to put in the bucket along with 1, 23. Now let's have another one here is 34. 34 is going to be, remainder 11 is right here, 1. So it's going to be put right here in the same bucket with 1, 23. Now, please note that here the current table size is 11, and the number of keys is right now is 5. The current load. So what is the current load? Current load is the percentage. It's how to measure how full is the table. So you use the number of keys divided by 11. So you get this 45%. That's the current load factor. And this is threshold. If you're going to exceed 50%, you're going to now increase the table size and rehash all the keys. I'm going to change this to 75%. So I'm going to change this to 75%. So this is 75%. So I'm going to add one more here. 45. 45 is here. So this is 55. So let's add is here is I'm going to add at 10. So 10 is going to be right here. So look, this is 64. So now let's add another one. I'm going to have another one here is 30. I'm going to have 9. So let's put 9 right here. So I'm going to insert 9. All right, 73. So watch. If you add another one, so the other one, another one I'm going to add is let's do this. 20. If you insert this 20, the load factor, current load factor, will exceed 75%, exceed the threshold. So we need to double the size of the table and rehash everything. So now let's see what happens. Insert. All right, so now your size is doubled, is 22. And look at the table. Now everything's rehashed. So the load factor is now reduced. So this 9 divided by 22. So this is 41%. So this is, and for all the other animation we have the same thing here, is the table size and number of the keys and the current load factor and load factor threshold. So all here. Now the next section, it is just revisit this definition for load factor and rehashing. So the load factor is very important. If you have a very high load factor threshold, and so the performance will be impacted. But if you have a very small load factor threshold, and then you're going to have a problem as you have waste a lot of space. So there's a trade-off. So normally, I think 75% is good, is reasonable, and 50% it's also good. It actually improves the performance better than 75%, but waste more space. That is all for this two sections on handling collisions using separate chaining and load factor. We discussed load factor threshold and rehashing. See you next time.